The last part of section 2.7 is about absolute value inequalities. And I can pretty much think about 5 different cases. So 5 cases. So either you have an inequality of the form x and absolute value is less or equal to k. Now I'm running a big X here because it's not just the variable x. It could be like an expression, like an entire expression. So that could be like 2x plus 3. Okay, it could be your favorite expression. Okay, it could come. This big X can include a lot of things here. So it's the absolute value of something. So instead of saying something, I wrote big X is less or equal to k, where k is positive. Maybe you have the absolute value of something is less or equal to 0. Maybe the absolute value of something is less or equal to k, where k is negative. Maybe you've got absolute value of something is greater or equal to k, where k is positive. And finally, absolute value of something is greater or equal to k, where k is less or equal to 0. So notice I'm including the case where k is 0 here. So let's look at each of them. So if the absolute value of something is less or equal to k, where k is positive, okay, what's the absolute value again? This absolute value is the distance to 0. So that means the distance is no more than k. Okay. So it could be here, this is the distance of k, this is the distance of k, in which case you'd end up at minus k. So that means you can be between here and here. Okay? So in other words, your expression could be anywhere between k and minus k. So to solve this, we will be solving these two inequalities that we can actually regroup into one line. If the distance is less or equal to 0, well, the distance cannot be less than 0 strictly. So it has to be, if it's less or equal to 0, the only possibility is that it's equal to 0. So this is exactly the same as saying that the distance to the origin is 0. That's exactly the same thing. So in which case, we are exactly at 0. So this one is exactly the same thing as saying that what's inside the absolute value is 0. That's the only way of satisfying this inequality. If the distance is less or equal to k, where k is negative, you cannot have a distance that's less than a negative number. The distance would be to the origin would always be a positive number. So here it's not possible. So there would be no solution here, okay? Okay. If x is, the distance is greater or equal to k, oh well, this one's interesting. So this is 0, this is a distance of, let's say, k. So this is k, distance of k. Again. Here where the distance is greater or equal to k. So maybe we're here or we are here. So that would lead to what's inside the absolute value. Okay, it's going to be either a number that's greater or equal to k, so that its distance is greater than k, or it would be less or equal to minus k, so that again its distance is greater or equal to k. So I would have this or this or this. And finally, if x is, if the distance is greater or equal to 0 or a negative number, well, the distance is greater or equal to 0 or a negative number. So that's always true. So here, the solution is everything. So that means that the answer would be all real numbers. Okay, or if you prefer in interval notation, anything from minus infinity to infinity would satisfy this. So I'm going to look at some examples here. Okay. So consider the curve y equals minus a half, absolute value of 4x minus 5. Okay, we could try to figure out what that curve is by plugging in some values of x, figuring out the values of y. Okay, we're going to come up later on with a more efficient way of doing that. But we're going to want to determine the x values where the graph lies below the x-axis. Okay, so we've got some curve. We don't know what it looks like. And maybe like this. Okay, we'll see that that's really not how it looks like. But if we're on to figure out the values of x where the curve lies below the x-axis, so it would be, if that's the correct graph, it'd be those x values here and those x values there, because the graph is below the x-axis for those x values. So what do we want to know? We want to know when y is negative, right? This occurs, right? We're below the x-axis when y is negative. So we want to solve here the inequality minus a half 4x minus 5 less than 0. Oh, I forgot. There's a little 3 that I forgot in the statement, just to make it more exciting. Plus 3 less than 0. So let's solve for this. So the first thing you want to do is solve for your absolute value, okay? And then after that, you can figure out which case you're in. So let's solve for the absolute value. Keep in mind we've got an inequality, so if you multiply by negatives or divide by negatives, that's going to change the direction of the inequality. So I'm going to get rid of the 3, so I send the 3 on the other side. I multiply by minus 2, right? So this is going to change the direction of the inequality. So multiplying by minus 2, I'm going to get a 6 here. Okay, so what I have here, I'm in the case where I've got the absolute value of something is greater than 6. Okay, so instead of trying to figure out, okay, which case am I in, try to just take your time, think about your real line. If the absolute value is greater than 6, that means that the distance has to be greater than 6. So you're going to end up either, actually, we're not going to pull full dots because it's a strict inequality. Okay, this is where we should be. Okay. So we are in, if you want to know, we are in, even myself have to look at this. We are in case number 4, okay? But it's a lot easier just to think about, like, do that step in your head on paper, and then just by pure logic, you're going to figure out, okay, what x needs, your expression inside the absolute value, what it should be. So here I know that 4x minus 5, one possibility is that it's less than minus 6. Okay, so which would be here. Or we could be above 6. Or 4x minus 5 is above 6. So I end up with 2 linear inequalities to solve. So I need to solve them separately. So I add 5 here, divide by 4. So any x less than minus 1/4 would do. Or if I solve for x here, if I'm greater than 11, x greater than 11/4 would also do. So essentially, on my real line, the solutions are when you're above 11/4 or below minus 1/4. So I'm going to write that in interval notation. So if I'm below minus 1/4, so minus 1/4 is not included. Or is union, right? Because I'm adding the other possibilities. Like that. So this is where x could be. Okay. In fact, when we're going to graph this curve, I would be between, we would be negative below minus 1/4. So actually that's how the graph is going to look like this, and above 11/4. So this is 11/4 here, and this is minus 1/4. You wouldn't know right now why it looks, it has a pointy shape like this. Okay, we're going to see that later on in the course. But what you need to understand is that we found out that here and here the graph lies below the x-axis. let's look at some other examples. So solve. Maybe you want to do those by yourself. Minus a half, 4x minus 5, minus 3, less than 0. Okay, let's try that. Once again, you want to solve for the absolute value. You want to have absolute value of something, on one side. So I'm going to get rid of the minus 3. Okay, multiply by 2, minus 2 on both sides, changing the direction of the inequality. And then I get, the absolute value, which is the distance to 0, needs to be greater than minus 6. Well, a distance is always greater than minus 6. So this is all real numbers will work. Any x will have its absolute value greater than minus 6. Here's another one. We're going to solve 3x minus 2 in absolute value is equal to 0. So when is the distance equal to 0? Well, what's inside the absolute value has to be 0. That's the only way for the distance to be 0. So that's the same thing as writing 3x minus 2 equals 0. So this is actually the only case where you can sort of remove the absolute value and not worry about it. If you've got something like this, you cannot just remove the absolute values, right? So that's only going to work if it's a 0, because 0 is the only number that's at a distance of 0 from the origin. So here we just solve for x, we get 2/3. Okay, and finally maybe another one, solve absolute value of 3x minus 1 less or equal to 2. So if we think about this, this is of the form absolute value of x less or equal to 2. So our expression, could be anywhere between 2 and minus 2. And it would work. So I need 3x minus 1 to be between 2 and minus 2. Notice that here I can actually write it down on a single, as I don't have to split it into two inequalities. You can, but you don't have to. Oops, I'm going to keep this. So here you can play with this by performing operations. Now I've got like 3 parts where I can actually, I need to perform the same operation. So I add 1 everywhere. Minus 2 plus 1 is minus 1. Divide by 3. 3 is positive, so it's not changing the direction of the inequalities. Then we get this. So finally, we're between minus 1/3 and 1. Okay. Notice, by the way, if this is like a, let's say minus 3, you divide by minus 3 on both sides, it would change the sign of all the inequalities, right? It would actually, both of them would actually change direction. But this is not what's happening here, so let me rewrite it as it was. Maybe it's just better if I just start from scratch. Like that.